Hello friends, welcome to my channel. In this video I am going to discuss about electric potential due to a point charge. Okay, so we need to find out electric potential produced by a point charge. So I am considered as a plus Q charge. Okay, this plus Q charge, from this plus Q charge, okay, from this plus Q charge, r distance, there is a point is there, that is P. Okay, how much is the distance? This P point, r distance. So I need to find out electric potential at this P point. Okay, what is the electric potential at this P point due to this point charge? This is a point charge. Clear? Okay, this is a point charge. Clear? Okay. What is the electric potential formula? Electric potential means it is the amount of work done to bring a unit positive charge from infinity to this point. So what we need to find out, if we need to find out electric potential at this point P, we need to calculate what is the work done to bring a unit positive charge from infinity to this point. Clear? Okay. So I am consider this is my point of infinity. Clear? This is my point of infinity, and instead of bringing unit positive charge, I am to be noted as Q naught. Okay, I am bringing this Q naught from infinity to this point. Okay, so here you see electric potential at this point means it is the amount of work done to bring a unit, that is Q naught, from this point P divided with this Q naught, that work done. Then we will get the electric potential at the P point. Okay. Here you see, while at infinity, this is a positive charge, this is a positive charge. The repulsion of this charge on this charge is very smaller. So I have to exert a very less force. But coming closer and closer, what will be happen? The repulsion is increases even though I have to apply a force. So what will be happen here? You see that the external force is in this direction. This is the external force, and the electric field, electrostatic force, is in this direction. So this is in the opposite direction. I have to overcome this force, and I have to bring, or any other external agency has to overcome this electrostatic force and has to bring. So here you see that it is a work done by a variable force. Okay, so for calculating work done by variable force, what I am going to do means, I am going to consider a small distance. I am going to consider as a small point P dash, that is in between infinity to P. Okay, this P dash point is how much distance? That P dash point is r dash distance from the point charge. Okay, from this P dash point, I am going to consider a small distance delta r dash. Okay, for bringing this Q naught charge from P dash to small distance dr dash, how much is the work done? I am going to calculate. Then I will be integrate from infinity to P. Then I will get the total work done. So I am using that method for this calculation. Okay. So here what we are going to find out, work done to bring the Q naught charge in delta r dash distance. That is a small distance, so the work done is small work done. So delta W. Okay. So what is the work done formula? Here in the small distance, the electrostatic force is to be what? It is to be constant. So we can use which formula? work done have two formula. One is integration of f of x dx, or another dot product of force into displacement. Here force is constant, so we can use f dot s, that is f dot r we can use. Here what is the displacement? So we are using f external dot delta r dash, that is the displacement. Clear? So the displacement is in this direction. Clear? This is the displacement direction. F external direction is in this direction. Two are in the same direction. So f external modulus of f external into delta r dash cos theta dot product. Cos theta is here is 0 because delta r dash and f external are in the same direction. Clear? Okay. So this modulus f external I am simply writing as f external. So f external into delta r dash, like that we can write. If we are going to find out the work done by the electric field, so what we will apply? We will substitute the electrostatic force. Here you can see that this electrostatic force is in the opposite direction of external force. So we will put a minus sign here, Fe. Okay, so this force is to be equal to this, because we are bringing the charge from infinity to the P point is what? Infinitely slow with a zero acceleration. That we already discussed in the topic work done to move a charge in an electric field. Okay, so that we already did. This is the work done. Okay, so what is this? What is this Fe? Fe is equal to what? This is a Coulomb force. The force exerted by this, what is this force exerted by this Q naught charge in this P dash point? What is the force exerted by this? So that is equal to Q naught into E. That is a minus sign is there, into delta R dash. What is E? E is the electric field. E is the electric field at P dash point. That P dash point is a R dash distance from the capital Q. So the electric field produced by a point charge is, what is the formula? 1 by 4 pi epsilon naught capital Q divided by R dash square into delta R dash. This is the work done to move in a delta R distance. Okay. But electric potential means work done to move from infinity to P point. Okay, so total work done to move Q naught charge from infinity to P is what? W, that is equal to integration of infinity to P delta W. Okay, this delta coming to inside become dW. Okay, so how much it is that? Infinity to P minus Q naught 1 by 4 pi epsilon naught capital Q R dash square into delta R dash. That is the work done to move Q naught charge from infinity to P. Okay. Electric potential means what? Electric potential means work done to bring a unit positive charge. So electric potential at the P point is work done to bring a Q naught from infinity to P divided by Q naught. So that means what we'll do? Infinity to P minus this, here this Q naught is a constant, I'll take it outside, 1 by 4 pi epsilon naught capital Q divided by R dash square. In the integration, this is delta R dash divided by Q naught. This Q naught and Q naught is cancelled. What is remaining? Integration of 1 by 4 pi epsilon 0 Q by R. Here this is to be constant. What is the constant? Q by 4 pi epsilon naught is a constant. We'll take the integration from infinity to P 1 by R dash square dr dash. Okay, this we can write like this. Vp is equal to Q divided by 4 pi epsilon naught integration of infinity to P R dash power minus 2 dr dash we are getting. Okay. So this is in which form? Integration of x power n dx. Instead of x r dash and instead of n minus 2. What is the integration of x power n dx? Integration of x power n dx is equal to x power n plus 1 divided by n plus 1. So here what you will get? Vp is equal to Q divided by 4 pi. This you take it as in a box. 1 by 4 pi epsilon 0. What is the integration? Integration here will come r power minus 2 plus 1 divided by minus 2 plus 1. Clear? Upper limit is p. P is in how much distance from it? R distance from it. So we'll write here r to infinity. Clear? Okay. That we can write like this. Vp is equal to Q divided by 4 pi epsilon naught minus 1 by r dash infinity to r. Clear? There we will get what? There we will get r dash power minus 1 divided by minus 1. That we can write like this. Okay? Clear? Okay. Then this now you are going to apply upper limit and lower limit. So Q divided by 4 pi epsilon naught. This minus, already one minus is here because the work done is to be minus already here. I forgot to write in the previous steps. This minus, previously the work done is a negative. So that negative sign is to be there. I missed in the previous steps. So you just see that. Okay. Okay. So this minus and that minus become positive. So Q divided by 4 pi epsilon 0 1 divided by r dash into infinity to r. First you apply upper limit. Q divided by 4 pi epsilon naught instead of r dash r. 1 by r minus 1 by infinity. What is 1 by infinity? 1 by infinity is equal to 0. So Q divided by 4 pi epsilon 0 r. 1 by r. So electric potential at a point due to a point charge Vp is equal to what? 1 divided by 4 pi epsilon 0 Q divided by r. Okay? Okay. If Q is greater than 0, Q is greater than 0 means positive charges. What about Vp? Vp is to be greater than 0. If Q is less than 0, that means for a negative charges, Vp is less than 0. Here you see that electric potential is inversely proportional to distance. That means from Q charge, the distance will be increases, the electric potential value will be decreases. Clear? This is the electric potential due to a point charge. Thank you for watching the video. Please subscribe my channel. If you like this video, please put like.